So I clicked on this video because you want to find out how do I solve word problems using matrices. In this video, I'm going to show you exactly that. Now, if you don't know the basics on how to apply math operations on matrices, consider clicking on the links up here to go through those basics. And then you can come back and try to apply those basic skills into solving word problems. Now, if this is your first time coming to my channel, my name is Peter. I make math tutorial videos to help students learn different math concepts. Now, making these videos requires a lot of effort and time, and I'll greatly appreciate it if you subscribe to the channel, like the video, and share it with a friend or somebody that would find this content useful. Now, with that said, grab your calculator and let's get started. To solve a system of equations using 2x2 matrices, let's review some of the skills that you need to be able to do this. So number one, you need to be able to determine if a matrix is invertible. And to do that, you need the second skill, which is to calculate the determinant and see if it's equal to 0. Number three, calculate the inverse. And then number four, solve the system. So these are the skills that you need. If you forgot how any of these skills, please watch the links are in the description box below, and then you can watch this video. So how do you solve a system? I'm going to show you sort of the general process on how to do this, and then we'll actually use a real life problem to be able to apply this concept. So the first thing is, if you have a matrix A times your variable matrix X time equals to B, this is the format that you're going to have whenever you want to solve a system. We know from matrix A it has values. X represents a matrix that has the unknown variables X and Y, and then B are also values that we know. So now, how do we solve this system here? We need to figure out how do we get rid of this A here. So we get rid of A by multiplying by its inverse times X, and it's equal to, now when you multiply by the inverse on the left side, you have to do the same thing on the right side, multiply B by the inverse of A. So if you multiply this side by something, you do the same thing on the right side. Now let's try to understand why we're multiplying by the inverse. Whenever you have an equation and you're trying to figure out how do you get rid of the coefficient of a variable, you always divide by that coefficient. So if I want to get X by itself, I would sort of divide both sides by A. Now we know that in matrices we do not have the division operation for matrices, but this is sort of like the general idea. We want to get rid of the matrix A by multiplying by its inverse, and that product will remove that coefficient and we remain with our unknown. So this is sort of what we're doing behind the scenes when we do this. So when you multiply those two matrices, you get the identity matrix times X is equal to A inverse times B, and whenever you multiply any matrix times the identity matrix, you get back the same matrix, that is going to be X is equal to A inverse times B. When you have this the X matrix, the unknown variable matrix, alone on one side, then you'll be able to get the solutions for that system. So now let's take a look at some examples. So the next couple of problems are going to be word problems, and we're going to be using matrices to solve them. The first question here, find the value of two numbers if their sum is 12 and their difference is 4. This word problem is pretty easy. You don't have to use matrices. You can just use like a guessing method and you'll get the answers pretty easily. But we're going to focus on matrices so that we can practice how to find a determinant, how to figure out if a matrix is invertible, how to find an inverse, and then obviously how to solve a word problem using matrices. So let's go ahead and solve this problem. The first thing we're going to do is we're going to come up with some equations, two equations, and the first one is going to be using this keyword sum and the number 12. So if I have two variables X and Y and I add them, I'm going to get 12. And if the second sentence here says difference is 4, so I'm going to subtract the two variables X minus Y and I'm going to get 4. So now from these two equations, I'm going to come up with matrices. And so the first matrix is going to be a 2x2 matrix that is made up of the coefficients of the variables. So in the first column, I'm going to have 1 and 1 representing the coefficients of X because they are invisible ones here. And the second column column is going to be 1, negative 1. These are the coefficients of the y variable, positive 1 and negative 1. Now the next matrix is going to be for the variables. So it's going to be a 2 by 1 matrix. X is going to be up here and y is going to be down here. We put the equal sign, and then the third matrix is 12, 4, which is going to be a 2 by 1 matrix. So this is going to be the representation that we're going to use matrices when we have two equations like this. So the next thing now is we want to remind ourselves, how do we solve the general form of solving a system using matrices? So recall the first matrix here, we can call it A. The second matrix here, we can call it X, which represents the variables. And the third matrix, we can call it B. So if you want to find the matrix X here, this is the solution that you want. What we want to do is we want to multiply the inverse of matrix A. We want to multiply the inverse of matrix A times B. So multiplying by B, because on the left side here, when I multiplied A times its inverse, that removed this matrix from the left side, and then I have to multiply the inverse on the right side. So now let's go through the process where we have to first of all find the determinant of the matrix. So now the next thing is, now let's go through the process of getting the inverse of that matrix. So to get the inverse of the matrix, remember the formula said that on the outside the coefficient is going to be the determinant 1 over the determinant. So to get the determinant of this matrix, we multiply 1 times negative 1, which is negative 1, and then 1 times 1 is 1, but we have to subtract those two numbers. So this is going to be the coefficient, and then now inside the matrix we need to switch A and D. So negative 1 goes in the top left corner, positive 1 goes in the bottom right corner, and then C and B remain the same positions, but we make them negative. And then now the next part is to multiply the coefficient times all the values inside. Now this step here, I'm going to use mental math. So if you don't know how I got the answers here, pause the video and just go through the process on paper to verify that we get the same answers. 1 over negative 1 minus 1, this fraction here is like 1 over negative 2. So if you multiply 1 over negative 2 times negative 1, that's going to give you a positive 1/2. This negative 1 here is the same negative 1 here and here. That means this coefficient, when you multiply it times this other two negative 1s, you're going to get the same fraction, 1 over 2. Now finally, here we have a positive 1. Positive 1 times 1 over negative 2 gives us negative 1 over 2. So this matrix here is the inverse. Now the final step here is, now we need to find our solution. So we're going to multiply the inverse, which we just calculated, times the matrix B, which is 12, 4. So again here, I'm going to use some mental math to figure out what X and Y is, but I'm going to be describing the calculations as I do them. So the first part is 1/2 times 12, it gives you a 6. 1/2 times 4 gives you a 2. So 6 plus 2 is 8. So 8 goes in the numerator. The second calculation is 1/2 times 12 is 6. Negative 1/2 times 4 is negative 2. So 6 plus negative 2 gives you positive 4. So this is the solution of this system of equations. And we can try and see if we can check and see if these values are the actual answers. 8 plus 4 is 12. So that is correct. 8 minus 4 is 4. And so that means that 8 and 4 are the solutions. The second example reads, the difference of two numbers is 3, their sum is 13, find the numbers. So this second example follows the same pattern as the first example. The keyword in the first sentence is difference. So that means our two variables, if you use X and Y, we're going to subtract them. X minus Y equals to 3. The second sentence says the sum is 13. So keyword sum means addition. So if you add X and Y, you get 13. So these are our two equations. The next thing is we come up with a matrix, 2 by 2 matrix made up of only the coefficients of the variables. So that matrix is going to be 1, 1, negative 1, and 1. When you look at the coefficients of X here, positive 1, that's why the first column here is 1 and 1. If you look at the coefficients for Y, here it's negative 1 and this is positive 1. That's why this column is like this. The second matrix is just going to be made up of the variables, and the third matrix is going to be made up of the sum sum and the difference. So the next part is now we write the expression where we're going to have only the variable on the left side, and then we are going to find the inverse of our given matrix and then multiply by the solutions, the 3 and the 13. So when you multiply the result 3 and 13 by the inverse, that will give us the values of x and y. So the first step, find the inverse of our 2 by 2 matrix, and this process involves getting the determinant and putting it under a 1. So when you multiply 1 times 1, you get 1. You put a minus sign, and then 1 times -1 is -1. You put it inside parentheses. And then inside the matrix, we are going to switch 1 and 1, but at the same number. So it's just 1 and 1. And then 1 and -1 are going to stay in the same position. We just change the sign. So -1 bottom left, and +1 top right. And then the next part here is to multiply all the values inside the matrix times the coefficient. So here I'm going to use mental math, and so if you have trouble finding how I got the answers, just pause the video and in each step and then do the calculation on paper. 1 minus -1 is the same as 1 plus 1, so the denominator here is going to be 2. Our coefficient is 1/2. So we're going to multiply 1/2 times every number inside the parentheses. So 1/2 times 1 is just 1/2. Now, since here we have a +1 and another +1, all those numbers are going to be 1/2. Now, the only number here is a -1, so that means that fraction is going to be -1/2, and the remaining value is 1/2. So this is the inverse. That means now if we want to find the value of the unknown variables x and y, we're going to multiply that inverse times the solutions here, the values, the sum and the difference, 3 and 13. And then the next part here, I'm also going to use some mental math to find the two values here. So if you multiply 1/2 times 3, that is 3/2. 1/2 times 13 is 13/2. When you add 3/2 plus 13/2, that's 16/2, and that simplifies to just the number 8. And then you repeat the process. -1/2 times 3 is -3/2. +1/2 times 13 is +13/2. So +13 plus -3/2 is +10/2, which is just a 5. So now let's see if these two numbers actually give us 3 and 13. If you subtract 8 minus 5, you get 3. So that's correct. And then the sum, if you add 8 plus 5, you get 13. So 8 and 5 are the solutions of the two variables. So the third example reads, Brenda's school is selling tickets to a spring musical. On the first day of ticket sales, the school sold 3 senior citizen tickets and 3 child tickets for a total of $75. The school took in $67 on the second day by selling 8 senior citizen tickets and 5 child tickets. What is the price of each senior citizen ticket and 1 child ticket? So the first thing we're going to do is come up with 2 equations that represent this math problem. The first equation here is 3 adult tickets, 3A, plus 9 child tickets, so 9C, is equal to 75. So I'm using A and C to represent the number of adults and the number of children. And then the second equation is 8A, which is 8 adult tickets and 5 child tickets, giving us a total of 67 tickets sold, $67 of ticket sales on the second day. So these are the 2 equations, and we're going to convert them into matrices. The first 2 by 2 matrix is going to have the coefficients of the variables 3, 9, 8, 5, and the second matrix is going to have the variables, and then the final matrix is going to have the ticket sales 75 and 67. The next part is now we need to isolate the variables. So we're going to have on the left side only the variables A, C, and then on the right side we're going to multiply the inverse of 3985 times the ticket sales 7567. So now that we have our expression here set up, the next thing is to find the inverse of this matrix. So to find the inverse of that matrix, what we need to do is to find the determinant and then put it underneath a 1 as a fraction. So 5 times 3 is 15 minus 8 times 9 is 72. So that's going to form the coefficient. And then inside the matrix, we're going to switch 5 and 3, and then we're going to make 8 and 9 negative. And then now we're going to multiply the coefficient here times all of the values inside here. 15 minus 72 is negative 57. So when you multiply that times 5, you get negative 5 over 57. And then when you multiply negative 9 times negative 1 over 57, and you simplify it, you get 3 over 19. And then when you multiply negative 8 times 1 over negative 57 is 8 over 57. And then finally, when you multiply 3 times negative 1 over 57 and simplify it, you get negative 1 over 19. So this matrix here is the inverse, which we're going to now multiply by the ticket sales, which were 75 and 67. And then finally now AC is equal to, so now you're going to multiply negative 5 over 57 times 75 plus 3 over 19 times 67, and you can do all of these calculations either by hand or using a calculator, and your final result here is going to be 4. And then to get the 7, what you're going to do is you're going to multiply 8 over 57 times 75 plus negative 1 over 19 times 67, and you get a 7 here. So A is 4, C is 7. So let's interpret what those two numbers mean. A represented the price of each senior citizen ticket, so it was $4, and C represents the cost of each child ticket, which is going to be $7. In the 3 examples that we just did, all the matrices had a determinant that was not 0. But what if you got a math problem where the determinant was 0? What does that mean? So in terms of the matrices, having a determinant that's 0, that means the matrix does not have an inverse. But then in terms of the context of the math problem, it means that the math problem has infinitely many solutions. Graphically, that math problem, if you had 2 linear equations, the 2 linear equations would actually just be the same line. So after going through those 3 examples, 2 easy examples and 1 challenging question, here are 3 questions, independent exercises that you can try on your own. Read each question, pause the video, try the question on paper, and then once you're done with answering the 3 questions, the answers are in the description box below. Well, there you go. That's how easy it is to use matrices to solve word problems. Please remember the answers are in the description box below for the independent exercises, and also subscribe to the channel, like the video, and also share it with somebody that'll find this content useful. Leave a comment below letting me know which math topic you'd like for me to cover. With that, I'll see you guys in the next video. Bye bye.